Welcome. This is a audio-visual presentation giving you some guidance on how to do revision. In this presentation, I'm going to give you the most effective way of revising. So if you watch this for 25, 30 minutes, this should save you an awful lot of time. It'll make you all targeted, clinical and methodical about your revision, and you'll come out the other end with a warm, fuzzy feeling, safe in the knowledge that you've done the best that you can do before your exams. Okay, so hang on for another half an hour. Should save you a lot of time and stress. Okay, there's a number of different ways to revise. This is the way that you're going to use. Okay, and it's because it works and it's been proven to have worked. So we've mapped it. There's been research. Okay, if you click on the web link, it's quite an old link, but it's still active because I've just checked, and it's an article that was reported on by the BBC News in the UK. And it gives it was a study where they monitored the effectiveness of different types of techniques of revision. So you can click on that and you can see how they all work. And there's one which is the best one that I'm going to describe to you now. But click on the link and you can maybe see some of the stuff you used to do when you were younger, like recording yourself talking and falling asleep, highlighting, underlining things, um, constantly reading over and over and over and trying to memorize things. All of those have got very, very low effectiveness when it comes to revising. Okay, so this presentation will hopefully give you the best strategy, but it must be distributed over time. So you have to revise early, and there's a very good reason why you do this. Okay, I'll give you an example in a moment of if what happens when you cram. And this is based on actual student data at the University of Southampton. But if you revise far enough out, don't be worried that you're going to forget it before the exam. Okay, short-term memory is not a good thing. Okay, long-term, if you truly understand a topic or a subtopic within a module, you can do the questions, you've aced all the tutorials, you're not going to suddenly forget that after 4 or 5 weeks. So if you revise it early on, then it means that in the days leading up to the exam, it's all light touch stuff. You can go back, just reacquaint yourself, look at the material, look at the questions, have a quick go at a few problems. Magically, your brain will know exactly what to do. Words and numbers will flow onto the page. You get it correct because you've remembered it, and you'll feel absolutely fine and on top of the world. Okay, that's how the brain works. If you cram everything at the last minute, it can't possibly assimilate everything and store it. Okay, so it's very much based on how your brain actually works. This is really important for the summer exams because you get 4 weeks off at Easter. Your Easter vacation is a month long, and it's strategically placed in terms of revision well before the exams. Now, I know that you'll have some topics after Easter, which are presented on the modules before the final week 12 and then the exams, but you can revise the bulk of the module, 70% of it, before those weeks. So you can do an awful lot in those 4 weeks. Then you come back and you'll not be stressing about trying to revise right at the end. So it's very important, and your brain will retain it between the Easter vacation and the summer exams. Please don't be concerned that you're magically going to forget all of your efforts. So here's an example. This is a module that I taught many years ago. The module will remain nameless, but I provided a multiple choice sort of set of questions and some revision aids on Blackboard, which is our virtual learning environment here at Southampton. I uploaded them many weeks out at the beginning of the module, and there was some activity on the Blackboard site. There was a small brief flurry about 3 weeks out from the exam, and you can see that in the first sort of red oval, the instances of accessing. All those students passed with very, very good marks. They did their revision early. Now, there was another exam for the students for this particular cohort, which was 3 days before this exam. And you can see the mass instance of accessing my revision aids. The most worrying one is that big blue bar, 48 students accessed the revision materials the day before the exam. The yellow bar, which you can hopefully just see of about 7 counts, that was on the day of the exam. Students accessing revision material, so hours before this exam. And then there was one student that accessed it all 3 days after the exam, maybe to see how well they'd done. There we go. Most of the students that accessed the revision materials for the first time the day before the exam failed. And this was a first year exam. 2 different types of learning. You might have heard these before, deep and surface, and the names really describe the types of learning. So here's some words. So deep learning is effectively truly understanding and knowing something. Surface learning is memorizing and the ability to reproduce things. So you look at things, you remember the thing, you can write it back out again. Surface learning is terrible for engineering problem solving, where you have to be mentally quite agile. And in terms of your cognitive ability, you need to be quite agile. We might ask you the same sort of questions in 5 or 6 different ways, and the methodology is subtly different to get through to a slightly different answer. All on the same topic, but we can give you slightly different parameters, or out of the 5 parameters that you need, we give you 4. We could ask you a different one, a different answer each time. Okay, you can't possibly memorize all of those different routes through the problem solving process. So surface learning really does fall down when it comes to engineering at Southampton. So you need a deep understanding, which means that you need to be able to do really truly understand part or all of a module. So this is the 3 stages of your revision. Okay, there's a pre-planning stage, which involves paper and colouring pens. Mapping stage, pretty much the same, paper and colouring pens. And then the actual learning and measuring your learning stage, which is, I guess, what you would consider the revision part. Stages 1 and 2 are really important because this gets you started. Okay, and that's the hardest bit of revision, I think, is actually sitting down and getting on with it and knowing what to do. So I'm going to tell you how to start right now. Okay, so the pre-planning stage. So empty your desk wherever you're going to be. Shut the door, turn off your phone. It's going to take you a couple of hours with some breaks. But get some blank pieces of paper, get your folders or wherever you keep all of your modules that you need to revise, all of the sort of the notes and things, get them out and get some colouring pens. Okay, you need to work out what you need to know. So you're going to go back to sort of the first couple of lectures, maybe on the internet, to sort of the module description, the syllabus, and you're going to cut and paste, write out whatever it might be, all the different subtopics. Now once you've done that, you need to cross out the ones that you don't need to know. And this might happen because on a module lead might say, I'm going to teach you this now, it's quite important, but this specific thing is not examined. There might be a number of reasons for that. It might be that it's quite difficult for us to measure your learning on that particular subtopic, or because explicitly on its own, there's no point because that set of skills is duplicated in another part of the module in terms of how you solve this problem is exactly the same as how you solve another one, or the same type of methodologies or whatever it might be appear somewhere else in the module many times. So we might have actually told you a few things that might not be in the exam. So you can cross those off straight away, okay? Which will already make your list a bit shorter. You can look at formulas. That's a really common question that we get asked as lecturers and teaching staff. What formulas will I get in the exam? Well, you can find out by looking at past papers. There might be formula booklets or actual equations and formulae within the paper. And you can ask your lecturer. Make sure you ask them far enough outside of the exam so you're not stressing about it. So you'll be able to see the kinds of things you might be given and the things that you might be expected to derive or know yourself. Everything else is fair game and could appear, okay? Now you need to go and look at past papers. They will give you an idea of the types of questions and the level of knowledge and understanding or cognitive ability that you need. So go through, just look at the papers. Do not look at the solutions at this stage or anything else. Just look at the papers and look at the kinds of questions. Have a read through. Look at the number of marks, because usually the number of marks is proportional to the amount of effort and the level at which you need to go into that particular topic. So a question might be, briefly explain the difference between the steady mechanical energy and Bernoulli's equation. What are the key differences? Okay, so that might be a short written question, 5 marks out of 100. So you know you need to write a paragraph or two. Or it could be, here are 5 variables, here's 5 lines of text, calculate the answer, 20 marks out of 100. In which case you know that you're going to have to spend about a fifth of the exam doing this question. Now, broadly in engineering, we get 2 different types of questions. Explanation type questions, which might test your knowledge and understanding of a thing, and then problem solving, which is the multiple variables, some lines of text, and calculate some answers. Generally, the explanation type questions are they certainly can be shorter, and they generally are. The problem-solving questions tend to be a little bit more in-depth, involved, test more of your engineering ability, and thus are worth more marks because they take longer and are more difficult. So we need to identify what we need to know. So we've got a list of hopefully everything in the module. And you've already written that down. So the next thing is to sort of divide up the module content. Now, the module lead might have done this for you. They might say this module is taught in 3 different blocks or 4 different blocks. So we'll do them in this order. That's quite useful. You need to break up the modules now. Otherwise, there's an insurmountable amount of stuff you think you need to revise, and it's very difficult to work out the order. And the order is quite important in how you do it. Otherwise, you'll just do it in a sort of a random order, and you won't really feel like you're getting anywhere. So once you've written out all the subtopics on the module, try and look at how the module is structured. Can you break it up into different blocks? Sort of if it's fluids, for example, inviscid and viscous. That's a nice distinction. There might be bits on heat engines or conservation principles that you can treat those as separate blocks. Look at the linkages as well between different parts of the module. Where does the ideal gas law stuff come in for thermofluids? Well, it comes in within the ideal gas law stuff, but also within heat engines and also within the steady flow energy equation in terms of enthalpy. So you can see that you need to know the ideal gas property of state equation, also how to calculate heat and work and efficiency, and also understand the different types of processes. So specifically the named ones, adiabatic, isochoric, isobaric, isothermal, those sort of things. Okay, so you can see how that links into other parts of the module. If it links into multiple parts of the module, it's far more important than others. So you need to make sure you understand that well, because it could appear in a number of different areas of that exam paper. So now you can kind of see which areas of module potentially have more weight, which are more important. Those are the ones that you need to prioritize to get to understand really well. Okay, and you can use this now as a basis to track your revision progress, so you can start ticking off the biggest lumps. So here is a thing called Bloom's taxonomy. Now, most lecturers at university would know all about this. It's basically a cognitive ability pyramid, starting with basic stuff, which is quite broad, going up to quite sort of high-level, complicated stuff, which is quite narrow. So here's some explanations that I've written out. Knowledge is just to know things, to be able to recite. If you know something, you can tell it to someone else. What you might not be able to do is to understand and explain it, and that's comprehension. So those 2 really underpin the sort of explanation type questions. The blue one, application and analysis, they really relate to the engineering problem solving, where we say, here's 4 lines of text or a paragraph, here's 5 variables, tell us what the efficiency is. So that's fine. Now you need to develop a methodology to solve this problem, how to combine those variables, what to do, what formula you might need in order to tell us what the answer is. And at the end, we might say, comment on the efficiency. Is it very good? Is it higher or lower than you expected? So then we'd expect you to know what it should be or could be and give an explanation as to why it's better or worse. So that's a sort of the higher level type of cognitive ability. So you'll see that the questions sort of map on to this pyramid. Cool. So there we go. Okay, so again, the sort of the knowledge is implied. You need to know things, otherwise you're going to fail abominably. The comprehension is those sort of short written explanation type questions, which you may get. And then the blue bit, certainly in the first year, application analysis comes with the problem solving elements of the exam questions. Okay, so that's stage 1 and 2. So the first stage is kind of these big maps, where hopefully you can now start to target your revision. Second stage is looking at past papers and mapping them onto that pyramid to see where we might ask certain things about certain bits of a module. And now the third bit is the revision strategy itself. Okay, so this is it. Learn the material, test yourself. If you didn't get it, reinforce and improve your understanding and knowledge, test yourself again. Once you're happy and you've passed all the tests, you've finished. Sounds a bit trite. Here's what we do. So hopefully you've done this already. You've not really realized it, but you've been doing it all throughout a lot of your modules. So you go to the lectures, you'll be given some further reading. Then we set you some tutorial questions. So that's your test and measure yourself. You do the tutorial questions. If you got them all right, you're done. Well done, you know it. If you didn't, then you might not have already done this, but hopefully you would have gone away, tried to relearn the material some other way, had another go at the same question or a different question on the same topic. So this is sort of this loop between learn, test, improve, and then finish. And that's the strategy that we need to use. You can now see why you need to do this early on. You can't do this at the last minute because it's quite involved. But this is how you get deep learning and really deep understanding and knowledge of a topic. So you've got your big map of the modules. First thing to probably do, so where to start stage 3, what bits of which module? Well, go through all of the module and score all the different subtopic areas out of 10, where 0 is low and 10 is you think you have absolute mastery over dimensional analysis, and there's no question we could possibly test or ask you that you couldn't get completely correct because you're so good at it. Okay, so you got a ranking from 0 to 10 across each module. And then you need to look at the linkages. So then look at which bits of the module sort of cross-cut between different areas. Okay, so try and find the lowest scoring and the widest used bits of a module. They're the ones you need to start with and really get this deep understanding going. So go back, read the notes, learn some other way, and start doing this test and reinforce loop until you've boosted that score up to 8, 9, or 10. Okay, and then just go through different modules and with this process. If you're not sure what the score should be for a different certain type, then either maybe go back through your tutorial sheets and see which ones you did well in and which you didn't, or start afresh and just try and answer a question on each one and see how you do. Okay, so you read the notes and you didn't get it. Okay, dimensional analysis and thermofluids was completely impenetrable. You have no idea what you were doing, what it's for. Buckingham pie sounds like something you eat. What do you do? Well, you don't sit in a corner and cry. You try and learn some other way. So if you didn't get the lecture notes, didn't understand that, there are many other learning resources and further learning that you can use. Hyperphysics is a very good one for engineering. It's a very basic website in terms of it doesn't go into a huge amount of detail, but it does give you the key equations, little Java applets on how to calculate different things, and it's quite colourful and useful. So that's a good one to Google. Other search engines do exist. Having said that, Google Books is good. So again, the Hartley Library has a large number of books in print. Also, we have many ebooks available as well through the library. But you can always just use Google Books if you want to find something. So there's all those sort of types of resources, textbooks and things. The advantage with textbooks is some actually give you tutorial questions at the end of a chapter, and sometimes the answers as well. So that's quite good. So if you find a good book, you can actually unlock an extra bank of questions that you can use. Just be careful with the American textbooks because they still use imperial units. So it's a bit difficult. So what you might need to do is then convert into SI units, but otherwise hopefully most books should be using SI units for problems. YouTube is a good one. Again, don't want to highlight Google, but it does seem to work quite well. If you type in conservation of momentum and click on the video little button, then it will reel off a whole bunch of YouTube videos with people giving you a tutorial on conservation of momentum. So you can see it taught by someone completely different. And some people like doing this, going to different types of resources to get explanations on different things. So you're not just using the same thing all the time. Engineering Toolbox is a good website. There's quite a lot of instructional stuff on there. Very good for all of your engineering coefficients. So you need to know the density of polystyrene or A6 stainless steel. You can find it there. But otherwise, there's a lot of good tutorial stuff on a wide range of engineering topics. eFunder, Wikipedia. Wikipedia is okay. It's overly long because members of the public, when an account, can chime in. So each the specific page on whatever you want to search on Wikipedia is likely to be 8 times longer than it should be because everyone's decided to add their little bit on that topic. So if you want a short answer, Wikipedia is not always the best. Khan Academy was set up a few years ago. That's very good. And the university has a subscription to lynda.com. So if you go to lynda.com, you can sign in via your university account, and that will give you access to thousands of instructional and tutorial videos. So there's many different resources you can find online. So the testing yourself bit of stage 3. So you can use past exam papers, problem sheets, tutorials, worked examples from other textbooks, and also your own questions. That's useful for definitions. So you can go through a module and pick out all of the key bits and say to yourself, could I explain how that works or what it does or what it is? So can I explain the difference between a streamline and a stream tube? What are the key differences? What's the difference between the steady mechanical energy equation and Bernoulli equation? So you could actually, in your head or on paper, write these out and test yourself. That's good for the explanation type questions, the shorter questions that you might get. Okay, the key thing is if you don't get it, if you test yourself and you've not got the first foggiest idea of how to continue, you get stuck or you get completely the wrong answer, is to stop. Try and understand where you went wrong and then go back and learn some more so that you don't repeat the same mistake. If you don't get a certain topic and you keep testing yourself, you'll keep getting the wrong answers. If you got it wrong the first time, it's most likely you'll get it wrong the second, the third, the fourth, the fifth. All you do is you burn through all of your questions and you waste them. Because then when you actually do learn the stuff and go back through, you've already seen the solutions when you went wrong. So you actually lull yourself into a false sense of security. You think you can do it perfectly, when actually what you've done is you've looked at the solution, sort of memorized the key bits, and then fooled yourself into thinking you know how to do it. So use the test questions really carefully. If you're really good, you can actually preserve the exam papers, the past papers, for actually sitting down and doing the whole paper as like a sort of a mock exam in the library or in your room with no distractions. But yeah, don't stop doing the questions if you're getting them wrong. You need to sort out the problem, which is that you don't fundamentally understand that area of the module. Okay, I've literally just said this, but don't keep doing the same thing. If you're getting it wrong, you've got to do it differently. So if you got an explanation from somewhere, you tested it yourself and you got it wrong, maybe you didn't get it. So try it from somewhere else. Learn more and try and target your efforts as well. Okay. If you're not getting something after an hour or so, park it, leave it to one side, go on to a different module, do some revision on that, choose something that you're pretty good at to make yourself feel better, tick that off in whatever other coloured pen you want, and then go back the next day. Okay, don't just bang your head against a brick wall. That never works. And actually, that sort of notion of distributing your efforts is really important as well. So if you've got mechanics, fluids, and materials to revise, then do a morning or a couple of hours of fluids and then move on to materials and then do some mechanics and then go back to the fluids again. Don't just hammer a module for days on end until you think you finished it. It's really important for your mental well-being and also your brain that you split it up. So if you've split each module into little bits, do a bit on that module and then choose a different module. Just because you're mixing it up actually makes it more effective in terms of revision and not less effective. And again, there's been studies to show that if you distribute and mix up your revision between different subject areas, you're more likely to retain that knowledge. Okay, stage 3.4. So you've learned some stuff, you've tested yourself, you've got it pretty much all correct. Well done. Mark it off in red pen, big tick. You can use whatever color pen you like. Now the second bullet point on this slide is very important. So you've done it, well done. You're not quite finished. Because you've revised so far out early enough, what you can do just before the exam is just go back over that sort of subtopic, have a quick read, maybe do a question if you want to, but just pull the deep knowledge out from the back of your brain. Just remind yourself that you do know it, you got the question right, and then you should be all right for the exam, which means that in the days leading up to the exam, immediately before it, you're not doing too much work, you're just recalling the stuff you've already done. In the summer exams, if you revise over Easter, you'll be amazed that you can go 3 days before the exam, just quickly skim over the material, have a quick look, and during the exam, if that stuff comes up, you'll be well placed to answer it as well as you did over the Easter period when you got all of the questions correct that you tried. Your brain works very well like that. That's deep knowledge. You've not surface learnt it. You've not tried to memorize anything. You fundamentally know how to do it, and your brain doesn't forget it. If you've done it for a few hours, got it all right in April, you can get to the beginning of June and be able to recreate that. So that's how your brain works. So don't panic. So final advice, really that issue of some parts of the module are quite important and they interlink between. Those are the ones you really need to get correct. Remember the pass mark is 40%. If you go to other countries, the pass mark will be 50, 60, 70. The ability you need to get those marks is almost equivalent. Okay, so don't be lulled into thinking 40 is easy. If you go to America and the pass mark at some institutions is 70, they have an incredibly steep grading curve. So if you think 40 is a lot easier than 70, it's not. It's pretty much the same. We just all start at a different number. If you don't know the key parts of a module, or you only know 40% of the module, then you're likely to get less than 40% in the exam because you won't get all of what you know completely correct. It's very difficult. So just think of it in that way. If you don't know the big parts of a module, you're going to get to the questions. There might be 6 questions, and you can answer a part of question 1 and a part of question 3 and a little bit of question 4. And you realise that's not even 40% of the available marks on the paper. Okay, so don't get lulled by this 40% pass mark that it's easy. Most of you, if not all of you, should be aiming as high as you possibly can, into the 70s if you can, to get a first class honours degree. So then you do need to do this revision in the way that I've described early enough and in good detail. Okay, this method will save you wasting an awful lot of energy and time in revision as well. So it means you can target your revision most effectively to get those really, really high grades. Okay, so hopefully this is all sunk in. Hopefully this has been just under 30 minutes of very useful guidance. And if you follow it, you'll save far more than that in terms of time and effort. So good luck with your exams, whenever they might be. And that's enough from me. I'll just leave you with a final thing, which is a little bit of a cheesy quote, but it is quite true. Someone once said, "I'm a great believer in luck, and I find the harder I work, the more I have of it." So you might think it's lucky that the questions you revised came up in the exam, but if you've revised everything really well, you've revised all of your weakest areas to bring everything up to a certain high level, then there shouldn't be a question that you can't answer, or at least have a good attempt at. Um, the true definition of luck is only revising a tiny bit of a module and finding that only those areas come up on the exam paper. But just like gambling, the odds are stacked against you, so I wouldn't recommend that in the slightest. Okay, so work hard and you'll find that the questions are amazingly quite easy for you. Okay, thank you very much for listening.